awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Assalamualaikum and hi everyone. So, selamat kembali ke channel Maida Fika-Fiki. Jadi, bagi yang hadir bagi set 2 part 2, okay, saya yakin anda telah siap set 1 dan juga set 2 part 1. Okay, jadi sebelum saya teruskan bagi discussion part 2 untuk set 2 ini, okay, saya dapat satu komen daripada Rashikah Chin. Dia kata, Assalamualaikum Madam. Waalaikumsalam. Nak soft copy soalan set 1 dan 2 boleh? Okay, kita ada permintaan daripada sahabat kita Rashikah, di mana dia nak set soalan set 1 dan 2. Jadi, jika anda semua menekan description bagi video ini, okay, tekan dekat description video ni, saya ada sertakan satu link Google Drive. Okay, klik dekat link tersebut dan anda boleh dapatkan set soalan bagi set 1 dan 2 dan boleh download lah dalam Google Drive tersebut. Okay, jadi sekarang kita tak nak buang masa. Jom kita mula discussion untuk part 2 bagi set yang kedua ini. Jom kita mula. Okay, now we have question 6a and here we have a concave mirror. So remember, for concave mirror, okay, so the focal length of concave mirror should be positive sign. And the questions give us the value of the focal length is equal to positive 10 centimeter. Okay, so here I will highlight the sign. So this is very important. Okay, for concave mirror and convex lens, the focal length, the sign convention for the focal length is positive. Alright, so where the object should be placed to produce an image that is inverted and 2 times the size of the object. So this time we are given the condition where the magnification M is equal to 2, but the image is inverted so that M is equal to negative 2. Okay, so here we have negative sign to show you that the image produced is inverted. Okay, alright. So since the image produced is 2 times the size of the object, 2 kali ganda image yang terbentuk itu, size-nya 2 kali ganda daripada objek, means that the magnification M is equal to 2. Remember, the negative sign here showing you that the image is inverted, the value of 2 here showing you that the size of the image is 2 times the size of the object. Okay, so before we proceed, I want to recall some important information about magnification. Okay, when magnification is greater than 1, okay, 1.5, 2, so means that the image is magnified. Image lebih besar daripada size object. The image is magnified. Okay, but if the magnification value is equal to 1, means that the image is the same size as the object. Alright, and last one, when the magnification is less than 1, 0.9, okay, less than 1 ni maksud dia 0.9, 0.8, 0.5, alright. Kalau negative 1 bukan less than 1. Okay, kalau contoh macam negative 2 not less than negative 1. Negative means that the image is inverted, but the magnification is 2. Okay, so dia adalah lebih besar. So M less than 1 means that the image is smaller than the object. Okay, so the image is diminished. Okay, so this is very important. Okay, so now our M is equal to negative 2 since the question state that the image is inverted and 2 times the size of the object. So let's write the equation. 1 over F is equal to 1 over U plus 1 over V. So I will let this as my first equation. So we want to find where the object should be placed, means that we want to find the value of U. Okay, so dalam keadaan ni kita ada F, we want to find U but we don't have the value of V. Okay, so means that we need another equation, okay, which is m is equal to negative v over u. Alright, so from the second equation, let's substitute m is equal to negative 2 and here negative v over u. So you can cancel negative sign, therefore v is equal to 2 times u. And this is my second equation. Alright, so now let's substitute, okay, equation 2 into equation 1. Alright, so let's highlight. Okay, so it will equal to 1 over 10 is equal to 1 over u plus 1 over v. So since v is equal to 2u, so it's equal to 1 over 2u. Okay, so let's calculate 1 over 10 and it's equal to 3 over 2u. Okay, so therefore the final answer, okay, u is equal to, okay, 3 over 2 times 10. Okay, so it's equal to 15 centimeter. Okay, so the object is placed 15 centimeter in front of the concave mirror. Okay, so for 6b, all right, let's proceed. So here I have a diagram for question 6b. Okay, let's read the question first. So the figure shows a cylindrical glass rod. So here we have the cylindrical glass rod where the refractive index given is 1.5. Okay, so this glass rod is immersed in the water. So we have water here, okay, and one end of the rod is hemispherical surface. All right, so this is hemispherical surface with the radius of 20 millimeter. Find the image distance of a point object. So here we have the object here. If the object distance is 80 millimeter, all right, so the diagram showing us all the informations based on the question. Okay, so given that the refractive index of the water N is equal to 1.33, so the refractive index of the glass is 1.50, while the refractive index of the water is 1.33. Okay, so determine the position of the image. So when we want to calculate the position of the image, remember, okay, this question is about spherical refracting surface. So let's write the equation. So this is about spherical, okay, refracting surface. Okay, so let's highlight. Okay, so the equation is N1 over U, where N1 is the refractive index at where the object is located. In this case, the object is located at, so in this case, the object is located in the water. That means N1 is 1.33. Okay, so plus N2 over V, and it's equal to N2 minus N1 over R. Okay, so we will use this equation to solve this problem. All right, so now let's just substitute as we want to calculate the position of the image, which is V. Okay, so we can substitute the value of N, N1, N2, U, and also R. But for R here, okay, so the value of R here can be positive or negative. So look at here, this is the object and the object is facing the convex surface. Okay, so since the object is facing convex surface, means that R is positive. Okay, macam lens lah. Convex lens, F is equal to positive value, right? So R is positive value. So for the spherical refracting surface, okay, tengok pada kedudukan objek. So sekarang objek dekat sini, dia menghadap surface yang melengkung macam ni, which is convex surface. So the value of R here should be positive. Okay, so now let's substitute the value 1.33 for N1. Okay, since the object is in the water, over, so 80 millimeter. So here we have 80 millimeter. So I just put 80 since the question gives us that the radius, okay, since the questions give us the radius is equal to 20 millimeter. Okay, so all the length unit is in millimeter. Alright, so plus N2, so the N2 is referring to the refractive surface. So we refer to the glass, which is 1.50, and we want to find V. So here we can solve for V. So 1.50 minus 1.33, and R is positive 20 millimeter. Therefore, okay, press your calculator carefully. So V is equal to negative 184.6 millimeter. Okay, so this is my answer. And 6B2, state two characteristics of the image. Now let's write the two characteristics of the image. Okay, so look at here. Since V is equal to negative 184.6, okay, negative value means that the image is virtual. So I will write virtual. Okay, and second one, so since we know that all virtual images are upright and all real images are inverted. So we can write, since this is virtual image, so it will be upright image. Okay, so finish question 6B. Okay, so let's proceed to question 6C. Okay, 6C, a biologist uses a converging lens. Okay, so let's write converging lens. Converging lens. Okay, converging lens referring to the convex lens. Okay, so for convex lens, okay, you can see here for convex lens, F, the focal length, should be positive value. So it's given that the focal length is 24 centimeter, so positive 24 centimeter. Okay, to observe a sample of size, okay, where it is 2.5 centimeter. So let's take the size of the object is equal to 2.5 centimeter, and the object is located 18 centimeter in front of the lens. So U is equal to 18 centimeter. So let's calculate the image distance. So number one, this is very simple. We want to calculate the image distance. Okay, so just substitute all the values. Equal 1 over 18 plus 1 over V. Therefore, V is equal to negative 72 centimeter. Okay, make sure you practice to press your calculator carefully. Okay, jangan salah tekan calculator. Okay, number 2, calculate the size of the image. So we want to calculate the size of the image. So we can use equation of magnification M, where it's equal to negative V over U, and M also equal to height of the image over height of the object. So in this case, we want to find the size of the image, which is HI. So we can write equation of M, negative V over U, is equal to height of the image over height of the object. Therefore, height of the image is equal to negative V over U times height of the object. Okay, so let's write negative V is equal to negative 72, okay, over 18 centimeter times the height of the object, which is 2.5 centimeter. Therefore, the final answer is equal to 10 centimeter. Okay, kalau kita tengok tadi, the size of the object is 2.5 centimeter. Okay, kalau kita comparekan sekarang dengan size of the image, okay, maknanya image ini 4 kali ganda lebih besar daripada objek. So, kalau image 4 kali ganda lebih besar daripada objek, maknanya magnification kita mesti nilainya adalah 4. Okay, and kalau kita kira M is equal to negative V over U, kalau kita substitute nilai negative 72 over 18, okay, tekan calculator, kita akan dapat magnification is equal to 4. Okay, jadi remember magnification is equal to 4 and it is apa? And it is positive, right? So M is equal to 4 and it is positive. So bila nilai ini adalah nilai positif, saya dah kata dia adalah upright image. Okay, so betul lah all virtual image. So ini virtual image tadi. Okay, remember negative V means that virtual image, tapi kalau M kita negative means that it is inverted. This time, the value of M is positive means that the image is upright. Jadi betul lah, all virtual image is upright. Okay, dia adalah virtual and upright. So number 3, state 2 characteristics of the image form. So kita boleh cakap lah. Okay, number 3. Kita boleh bagi 3. Tapi dia nak 2, bagi 2 saja. Iaitu virtual. Okay. Upright. Okay. In case soalan nak 3, kita boleh tambah. Satu lagi adalah magnified. Okay. Now we finish question number 6. So let's proceed to question number 7. Okay. Question 7A. Okay. We have a coherent light of wavelength 633 nanometer from a HENE laser falls on a double slit. So this is about double slit. So let's write double slits. Okay. So always remember for double slits, untuk dark dia nanti dia ada special sikit. Okay. Dia tak follow. Okay. Look at here. For double slits, if the question state that, for example, second dark, okay, iaitu dark yang kedua. So second dark for double slits, M is equal to 1. Okay, dia kena tolak 1. Tapi kalau soalan sebut second order dark, okay, so M is equal to 2. Okay, but for bright, kalau bright tak apa, tak kisah. Second bright or second order bright, M is equal to 2. Okay, yang ni dia tak kisah. Cumanya bezanya adalah yang ini, second dark. Okay, jadi for second dark, for double slits, the number of order M mesti tolak 1 lah. Sebab second order dark, for double slit, M is equal to 1. Okay. So now let's take out all the information. So we have lambda is equal to 633 nanometer. And given that the slit separation is 0.103 millimeter. Okay. So now small d is equal to 0.103 times 10 power of negative 3 meter. Okay, millimeter kan. And interference pattern is produced on a screen, okay, where the position of the screen is 2.56 meter from the slits. Okay, so capital D is 2.56 meter. Okay, alright. So now we want to calculate the distance of the fourth bright fringes from the central bright. Okay, so question number 1. Okay, fourth bright fringes. Okay, that's mean M is equal to 4. Okay, so we want to calculate the distance from the central bright, okay, daripada tengah sampai ke bright yang keempat. So dia adalah, equationnya adalah YM, and we use equation YM for bright, which is M lambda D over D. Okay, jangan tak ingat formula mana nak pakai kan. Formula telah diberi. You kena tahulah bezakan. Soalan nak bright, guna yang bright. Jangan guna yang dark pula. Okay. So now let's substitute all the values. So since we want to calculate the fourth bright, so M, the number of order is 4. Okay. Lambda 633 exponent negative 9. And capital D is 2.56 over small d is 0.103 exponent negative 3. Press your calculator, 0.063 meter. So this is the answer. Okay. Alright, so number 2, the separation between two adjacent dark fringes. Okay, so now we talk about the separation between two adjacent dark fringes. Two adjacent, dark fringes. Ataupun dia kata two adjacent bright fringes. Tengok betul-betul ya. Sama ada dia tanya dark fringes ataupun bright fringes. Kalau dia sebut perkataan two adjacent, maknanya we can straightly use this equation of delta y is equal to lambda d over d. Memang formula delta y ni memang untuk kira the distance between two adjacent dark fringes ataupun two adjacent bright fringes. So boleh kita guna ni. We can substitute straightly lambda 633 exponent negative 9 and 2.56 over 0.103 times 10 negative 3. And the answer is 0.016 meter. Maknanya dia akan samalah untuk yang dark ataupun bright. So the separation between two adjacent dark fringes or bright fringes is equal to 0.016 meter. Baca soalan betul-betul. Tapi sekiranya, now let's look at here. If the questions asks you to find the separation between fifth bright ataupun separation between fifth bright and second bright. Contoh saya buat contoh. So let's say question, baca betul-betul soalan. Let's say if separations, question give you, question find the separation between fifth bright and second bright. Ni soalan lain. Contoh dia kata cari jarak antara fifth bright dengan second bright. Macam mana kita nak buat? Ini tak boleh guna formula yang ini. So delta y, formula for delta y only for two adjacent dark fringes or two adjacent bright fringes. If the question asks you to find what is the separation between fifth bright and the second bright, so you should write, kira asing-asing dulu. What is y, m untuk fifth bright? Kiralah dulu. Berapa guna formula bright? Yang tadi, yang kita buat tadi. Mana? Formulanya apa? M lambda d over d. Macam ni. Kira dulu berapa dapat. Lepas tu kira pula daripada central bright kepada second bright. Berapa? Masukkan nilai dia. And calculate here. So, bila dah kira kedua-duanya, so in order to calculate the separation between, so let's write separation between fifth bright and second bright. So it's equal to ym for fifth bright minus ym for the second bright. Lepas tu baru dapat jawapan. Boleh? Nampak beza separation between two adjacent dark or bright fringes tadi. You boleh guna equation yang ini. Straightly substitute in this equation. But if you want to calculate contoh separation between third dark, third dark and the first dark ke, fifth bright and the second bright ke, so apa lagi? Sixth bright and the fourth bright ke, so kena guna cara macam ini, kena kira satu-satu, tak boleh masuk dalam equation ini. Nanti tidak menjawab soalan. Alright, so let's continue. 7b. So 7b, we have a glass lens of refractive index 1.53 is coated with a thin film, where the refractive index of the thin film is 1.43. So no light is found to be reflected. Alright, so ini adalah keyword dia lah. No light is found to be reflected from the lens when the thickness of the film is 1.04 exponent negative 7 meter. So now we want to calculate the longest wavelength of the light that makes this possible. Okay, so let's draw first the layer. So here we have the glass, okay, where N is equal to 1.53. So we have the thin film, for example, here. So this is the film where N2 is 1.43 and this is air 1.00. Okay, so first of all, look at the question. The question state that, okay, no light is found. Apa maksud dia? Okay, no light is found to be reflected. Okay, so maknanya dia refer kepada disruptive. Okay, itu keyword dia. Kita kena tahu dulu dia disruptive ke konstruktif. Okay, nak pilih formula nanti takut salah guna formula. Okay, so now look at here, the ray from here, from air and then refracted, okay, on the thin film. So look at the refractive index from N1 to N2, from lower refractive index to higher refractive index. So there is a phase change of ray 1. And for the second one, okay, so same goes to the second one, from lower refractive index to higher refractive index. So there is a phase change as well. Okay, so since both has the phase change, so means that this is in phase. Sorry. So this is in phase. Okay, so sekarang kita akan tengok formula for in phase disruptive. Okay, so for in phase disruptive, the formula is 2NT equal to M plus half lambda. Okay, so look at here. The questions asks us to find the longest wavelength. Okay, the longest. Kenapa disebut the longest wavelength? Okay, so the longest wavelength referring to lambda lah. Okay, tengok pada sini. If you want to find lambda and it's equal to 2NT over M plus half. Okay, so in order to get the longest wavelength, lambda ni kita nak dapat paling maksimum, okay, the value of order M should be equal to 0. Okay, sebab kita tahu kan, kalau bawah ini lebih kecil, means that lambda yang ini akan jadi lagi besar. Okay, so since we want to get the smallest value of this part, which is the bottom fraction, okay, so the number of order M should be equal to 0. Kita kena pilih the smallest number. Okay, kalau M equal to 1, lambda ni akan jadi kecil lah pula. M equal to 2 pun sama. Okay, the wavelength here, the value of lambda here should be reduced. Okay, so dia dah tak jadi longest wavelength lah. Okay, so the keyword of the longest wavelength means that, okay, the number of order here M is equal to 0, so that the value of lambda ini akan jadi yang paling besar, okay, the longest wavelength. Alright, so let's calculate what is the value of lambda. Okay, so therefore, just substitute in the equation. Sekejap ya. Okay, so 2, N is the refractive index of the thin film. Alright, the coated film tadi 1.43, and this one T 1.04, exponent negative 7, divide, okay, M is equal to 0, so divide half. Okay, so therefore lambda will equal to 594, okay, 0.9 nanometer. Okay, so this is the answer. Alright, so finish 7B. Okay, so now look at question 7C. Okay, for 7C, we have visible light of wavelength lambda. So let's take out, lambda is equal to 550 nanometer. Okay, falls on a single slit and produce its second diffraction minimum. Okay, second diffraction minimum at angle of 45 degree relative to the incident direction of light. Alright, so means that when the angle is equal to 45 degree, so it will produce second minimum. Okay, second minimum. So M is equal to 2 lah. Okay, second minimum kita refer kepada dark fringe. Tapi sebab ini soalan apa tadi? Single slit. Okay, ini cerita pasal single slit. Okay, so maknanya the number of order ni, okay, dia akan follow. Okay, kalau double slit tadi, second dark or second minimum, M is equal to 1. Okay, so make sure you remember. Okay, so question number 1. Calculate the width of the slit. So we want to calculate the small d. So by using the equation d sine theta is equal to m lambda, we can find d, where d is equal to lambda over sine theta. Okay, so since we have information about second minimum, okay, at 45 degree, then we can find what is d. Okay, so let's take up. So let's substitute. So 2550 exponent negative 9 over sine 45. Okay, so the answer is 1.56 exponent negative 6 meter. For second part, okay, calculate the first minimum, okay, the first minimum angle produced. Okay, first minimum angle. Dia nak, okay, angle di mana first minimum tu M equal to 1 lah. First minimum. Okay, so M is equal to 1. So for the first minimum, we still use equation for the destructive. Okay, so d sine theta is equal to m lambda. Okay, so we want to calculate theta, where it's inverse sine, okay, m lambda over d. Okay, so let's substitute all the values. So theta should be equal to 20.64 degree. Okay, yang penting jangan salah guna formula. Okay, alright. So the last one, calculate the second order maximum if the light is falls on grating. So this is about diffraction gratings, okay, where the number of diffraction gratings is 200 lines per millimeter. So this is very interesting. So question 3, so the number of lines is given 200 lines per millimeter. So bila soalan kata per millimeter, in your calculation, please change to lines per meter. Okay, macam mana kita nak tukar? Okay, kalau masih tak tahu, jom kita buat. So this one is per millimeter, so I will write 200 lines per millimeter times, so millimeter kat bawah, satu lagi millimeter ke atas. So kita nak tukar millimeter kepada meter. Okay, so 1 meter 1000 millimeter. Okay, so we can cancel millimeter. Therefore, okay, n is equal to 200 exponent 3 lines per meter. Okay, lepas tu baru kita boleh kira lah. Okay, the second order maximum. So let's calculate the second order maximum. Okay, so kalau second order maximum, this is about diffraction gratings. Okay, remember this is diffraction gratings equation. Okay, d sine theta is equal to m lambda. Okay, so kita nak tengok lah. Dia kata soalan ni mungkin dia nak tanya ni angle ni, awak betulkan sikit. Okay, yang tadi tu the first minimum angle produced, this one the second order maximum. The first minimum angle produced, this one the second maximum angle produced. Okay, kita nak kira theta lah. Okay, pada angle berapa the second order maximum will be produced on the screen. Alright, so now since we know that where n is equal to 1 over d. So, sekarang kalau saya rearrange this equation, sin theta is equal to m lambda over d. Okay, so kalau tengok ini adalah 1 over d. Okay, so 1 over d is equal to n. So we can rewrite sin theta is equal to n m lambda. So from here we can find theta is equal to inverse sin times n is 200 exponent 3. Okay, 200 exponent 3 times 2 times 550 exponent negative 9. Okay, so theta is equal to 12.7 degree. Okay, so finish question number 7. So let's proceed to question number 8. Okay, question number 8, we have a light of wavelength 436 nanometer is shown on a sodium metal surface in a vacuum. Okay, so lambda is 436 nanometer. Okay, so calculate the energy possessed by a photon of light. So let's say this is the metal surface. Okay, so which is sodium metal surface. Okay, so given that the wavelength of the light, okay, and we want to calculate what is the energy of the photon E, which is equal to hc over lambda. So this is very simple. Okay, so just substitute the values. Okay, right, C exponent 8, and given that lambda is 436 nanometer. Alright, so the energy possessed by a photon is equal to 4.56 exponent negative 19 joule. Okay, so this is the answer. Okay, B. Okay, so B, if maximum wavelength of 650 nanometer is required to free a photoelectron from the metal surface, okay, so given that if lambda maximum is 650 nanometer is required to free a photoelectrons from the metal surface, calculate the work function of the metal. Okay, okay, so here we have the work function, okay, W naught. So remember, so the work function is equal to hf naught and it's equal to hc over lambda naught. Okay, so question said that lambda here, okay, if maximum wavelength 650 nanometer is required to free a photoelectron, calculate the work function. Okay, kenapa dia kata maximum wavelength? So kalau nilai ini maknanya lambda ini yang paling besar, okay, yang paling panjang, okay, the longest one is 650 nanometer. Okay, maknanya kalau hc bahagi dengan nombor yang besar bawah ni, E ini akan jadi kecil. Tapi soalan kata yang paling besar, okay, yang paling lambda ini paling maksimum adalah 650 nanometer, so that dia boleh release photoelectrons. Okay, so remember kita tahu E, the photon energy mesti lebih besar daripada work function energy in order to release photoelectrons. So in order to release photoelectrons, E must be bigger than W naught. Okay, but in this case, kalau dia dah kata lambda maksimum, paling maksimum tu maknanya kalau hc bagi nombor yang besar, E tu kecil lah. Maknanya paling kecil dia adalah berapa? Kalau lagi besar lambda ni, okay, energy of the photon akan jadi lagi kecil, so dia tak boleh nanti untuk release photoelectrons. Okay, so kita boleh kira lah W naught. Okay, W naught is equal to hc over lambda, right? Okay, so in this case, we will use lambda maximum lah. Sebab kita nak tengok berapa nilai work function tu. Okay, sebab dia dah kata lambda maksimum adalah berapa yang kat sini tadi. So, ini lambda maksimum. So, maknanya work function tu kita samakanlah. Lambda dia tu kita samakan. Okay. So, it's equal to 6.63 exponent negative 34 C, okay, over 650 times 10 power of negative 9. Okay, so in this case, okay, let's say the work function is 3.06 exponent negative 19 joule. Okay, so ini jawapannya lah. Okay, so kalau saya suruh awak kira kan, when lambda maximum is equal to 650 nanometer, berapa nilai energy of the photon? Okay, dia akan sama lah. Energy of the photon, Hc over lambda maximum tadi. Okay, awak substitute, awak akan dapat lah sama. 3.06 exponent negative 19 joule. Okay, so as we know, if the value of the photon, energy of photon is equal to the work function, okay, kalau sama, maksud dia apa tu? Ingat lagi? Okay, so kalau dia sama, sekejap ya. So, kalau ini sama, okay, maknanya kalau kita ada metal surface here, okay, so all the electrons, okay, dia masih di sini lah. Okay, dia belum lagi bergerak keluar. Okay, dia masih tak ada V lagi. So, V dia is equal to 0. Okay, sebab tu dia kata tadi lambda, okay, the wavelength, the maximum wavelength is equal to 650 nanometer is required to free a photoelectrons from the metal surface. Maknanya untuk inilah untuk keluarkan photoelectrons from the metal surface. So pada keadaan ini V masih samalah. Okay. So maknanya for the energy, photon energy, E equal to Hc over lambda. Okay, lambda paling maksimum sekali adalah tadi 650 nanometer. Kalau kita lambda tu dia jadi 670 nanometer contohnya, okay, so takkan ada elektron kat sini. Okay, langsung tak boleh freekan photoelectrons from the metal surface. Boleh? Okay, remember, if E less than work function means that no electron is ejected. Okay, langsung tak boleh keluarkan elektron lah. Okay. Tapi kalau E equal to the work function tadi, okay, so electron is ejected. Okay, untuk case yang ini tadi. Okay, electron is ejected, okay, dekat surface sahaja. Tapi kalau E, okay, the photon energy bigger than the work function, okay, maknanya akan ada electron yang emitted. Okay, electron is emitted. Okay, maknanya electron, the photoelectrons will be emitted. Okay, so dia ada nilai V dan dia ada kinetic energy dia. Kita boleh kira half mv squared. Okay, boleh? Masih ingat lagi? Okay, so untuk soalan ni kena faham lah. Okay, tengok kat sini kenapa kita kira work function dan lambda ini kita guna lambda maximum tadi of the light, okay, the maximum wavelength of the light, because kalau lambda yang bawah ini lagi besar daripada 650 nanometer, E ini akan jadi lagi kecil. Okay, so E tak boleh jadi lagi kecil daripada 3.06 exponent negative 19 joule, sebab if the energy of the photon is smaller than work function, okay, no electron is ejected. Sedangkan soalan dah sebut, when maximum wavelength of 650 nanometer is required to free a photoelectrons from the metal surface. So, maknanya dalam keadaan ini, okay, the photoelectron is free from the metal surface. Boleh? Okay, good. Okay, so C. So, now we want to calculate the maximum kinetic energy of photoelectrons extracted by radiation of wavelength 436 nanometer tadi. Okay, so let's write the general equation. Okay, so C, sekejap Okay, C Okay, general equation E is equal to W0 plus KE. Okay, so this is general equation. So we want to calculate the maximum kinetic energy and it's equal to E minus W0. Okay, so E tadi kita dah dapat for lambda is equal to 436 nanometer. Dekat part A tadi kita dah kira. Okay, the kinetic energy is equal to, so E 4.56 exponent negative 19. And the work function kita dah kira dekat part B tadi, 3.06 times 10 power of negative 19. So kalau kita tengok kat soalan C ni, okay, look at here, the value of photon energy, okay, 4.56 and this one is 3.06. So in this case, we can conclude that, so here E is bigger than W0. Okay, so when E is bigger than W0, maknanya tadi apa? Okay, akan ada photoelectrons emitted. Okay, so dia akan bergerak dengan speed of V. Okay, so kita boleh nampak lah sini 4.56. Okay, ini 3.06. So we can calculate the kinetic energy is equal to 1.5 exponent negative 19 joule. Okay, so this is the answer. Boleh? Okay, so finish question number 8. So let's proceed to question number 9. Okay, so for question number 9A, awak tengok ni dah ada solution. Kenapa? Sebab saya tadi dah record tapi saya tak tekan butang record. Okay, jadi saya dah penat dah nak tulis semula. So saya akan bacakan solution ni lah. Okay, so now let's look at question number 9. Electrons are accelerated by a potential difference of 1000 volt. Maknanya kita ada electron and then kita ada potential difference 1000 volt. So this potential difference will accelerate the electrons. Okay, so bila electron tu lalu dekat potential difference 1000 volt tu, so dia akan accelerated. So kita boleh kira dia punya speed of the electrons. Okay, so after passing through a very thin crystal, it is found that electrons are deflected through an angle of 5 degree. Okay, so if the potential difference is increased to twice its initial value, maknanya mula-mula kita buat 1000 volt, kita tengok speed dia berapa. Okay, and then kita increasekan dia punya potential difference which is 2 kali ganda, twice its initial value. Okay, 2000 lah. Okay, so question nak kita calculate the ratio of the new electron speed to the initial electron speed. Okay, so tengok dulu. Okay, saya akan tunjuk kat sini Okay, look at here. So we have initial and final. So look at the conservation of energy for electron. So before the electron move with the speed of V, so kat sini saya letak V0, maknanya dia refer kepada the initial speed. Kita ada dua condition. Pertama, semasa voltage kita, V0 kita ini adalah 1000. So ini adalah 1000 volt. Okay. Dan untuk ini, keadaan kedua final, di mana V prime kita 2 kali ganda V0. Where V prime is equal to 2000 volt. Okay, in this case. Okay, so by conservation of energy, so we can get this equation. This is the equation of the speed of the electron when passing the potential difference tadi. Okay, so it's equal to, okay, daripada sinilah. Okay, initially, electron dia akan ada potential energy. So the potential energy of the electron adalah charge of the electron times the potential difference yang kita guna untuk accelerate the electron tadi. And what happened after the electron is moving forward with the speed of V? So, potential energy of the electron akan bertukar kepada kinetic energy, which is half mv squared. Okay, so mana datangnya formula ni? Daripada sinilah. Okay, so the equation of the speed of the electron V, okay, is equal to 2E capital V is stand for the potential difference over the mass of the electron. And don't forget to take the square root. Okay, so this is the small v and I put V0 stand for speed of the electron before we increase the potential difference to 2000. Okay, so for the final condition, when the potential difference is twice its initial value tadi, 2 kali ganda V0, and it's equal to 2000 volt, right? Okay, we still use the same equation, but this time I put V prime, so this is the final speed, okay, after we increase the potential difference to 2000 tadi. Okay, so baca betul-betul pasal soalan ratio, dia nak the ratio of new electron speed. Maknanya dia nak new tu yang final lah, yang selepas kita increasekan potential difference tadi. Okay, so V prime over V0, bukan V0 over V prime. Sebab dia kata new electron speed to the initial electron speed. So let's substitute all the equations. So V prime square root 2e, okay, and V prime kita nak tulis 2000 pun boleh. Okay, ataupun saya letak sini twice, 2 kali ganda V0. Okay, 2 V0 over m. Okay, and over, okay, the initial speed is 2e, okay, V0 over m. Kalau kata tak nak masuk 2 V0 dengan V0 ni, awak boleh juga masukkan ini, terus saja ganti 2000 volt and this is 1000 volt. Sama juga. Okay, so cancel all the constants. So we have 2, okay, cancel 2, cancel e, and also the mass of the electron. Okay, kita boleh cancel lah. Alright, and simplify the equation. Okay, take the square root. So, kalau you masukkan 2000 ni, kalau masukkan nilai 2000 ni, dia boleh cancel lah ni. Macam tu. Sama juga, dia akan tinggal 2. So, square root 2. So, the answer of the ratio is 1.4142. Okay. And then, untuk part B pun sama. Saya lupa nak tekan butang record. Okay. Kita tengok part B ni pula. Calculate the wavelength associated with the electrons of higher speed. Okay, so electrons with higher speed, okay, kita refer kepada final condition. So this is the speed, VF, saya letak VF, okay, final speed, di mana bila kita gunakan potential difference VF kita tadi equal to 2000 volt. Okay, so when we substitute in this equation, we will get the value of the electron speed, which is equal to 2.65 exponent 7 meter per second. Okay, so kita boleh relate lah. If you can see here that the speed of the electron is depends or directly proportional with the potential difference. So kalau potential difference yang kita guna, okay, lebih besar, that's mean, okay, the speed of the electrons akan lebih besar. Electrons tu akan bergerak dengan lebih laju. Okay. So sekarang dia nak wavelength yang untuk elektron yang bergerak dengan higher speed tadi. Okay. So based on the de Broglie equation, okay, asalnya dia adalah lambda is equal to h over p. Okay. So this is momentum. P is the momentum of the electrons. So P is equal to mv. So let's substitute the value of V, which is the speed of the electrons tadi yang kita dah kira dekat sini. Boleh? So substitute the equation, tekan calculator. So lambda is equal to 2.75 exponent negative 11 meter. Okay? So finish question 9. Okay, sorry sebab saya dah tulis siap-siap. Sebab tadi saya dah bersemangat explain pasal question number 9. Sekali saya tengok, saya tak tekan butang record. Okay, so let's proceed to the last question, which is question number 10. Okay, last question. Question number 10. Okay, so calculate the mass defect in atomic mass unit. So the question state that we need to leave our answer in atomic mass unit for helium-32, which has an atomic mass. So the atomic mass is given. Okay, so let's calculate the mass defect. Okay, remember the equation for mass defect. Okay, so mass defect is delta M. Okay, so remember delta M can calculate by using delta M equal to, okay, Z, okay, the number of proton times the mass of proton plus the number of neutron times the mass of neutron minus M is the mass of nucleus. Okay, atau delta M is equal to Z times mass of hydrogen plus N Mn, okay, minus mass of atom. Okay, tengok betul-betul apa peperiksaan dia. Okay, so here we have mass of proton and minus mass of nucleus. But here we have mass of hydrogen, okay, but minus mass of atom. Jadi dekat sini soalan bagi atomic mass. So remember in exam, in the list of constant, okay, this mass of hydrogen is not given. It's not given, okay, in the list of constants. Yang dekat depan tu dia tak beri, okay? Tapi kalau dia bagi dalam soalan, then you ada mass of atom dan mass of hydrogen pun you ada, dia bagi dalam soalan, then you can use the second one. Okay? But for this case, I will use the first one. Okay? Saya akan guna yang ini. Kenapa? Because we don't have the value of hydrogen. Okay, saya assume kita dalam exam tu tak ada mass of hydrogen. Okay, jadi saya akan gunalah. But we need another step, okay, where we need to calculate M of the nucleus. Okay, where the mass of the nucleus, okay, is equal to mass of atom minus, okay, the number of proton times the mass of electron. Okay, so we need to use this one. So now let's find first, okay. So let's find the mass of the nucleus, which is equal to the mass of atom. Soalan dah beri 3.016030, okay, minus 2, and the mass of electron must be in unit U, and it is equal to 5.48 exponent negative 4U. Okay, yang ni dia bagi kat depan lah, so you boleh pakai. So the mass of nucleus is equal to 3.014934U. Okay, so therefore we can calculate delta M is equal to 2, and the mass of the proton, okay, dalam U adalah 1.007277, okay, plus the number of neutron, which is 1, and times the mass of neutron, okay, where the mass of neutron is 1.008664. Okay, mass of neutron and the mass of proton you boleh check kat depan. Okay, dekat depan dekat list of constant tu. Minus, this one is the mass of nucleus we have calculated just now, which is 3.014934U. Therefore, delta M is equal to 8.285 times 10 power of negative 3U. Okay, so dia tak nak dalam kg kan? Dia nak dalam unit U. Okay, kalau soalan nak dalam kg, boleh tukarlah dalam kg. Okay, di mana remember that 1U is equal to 1.66 exponent negative 27 kg. In case nak tukar dalam kg. Okay. Alright, next we want to calculate what is the binding energy per nucleon. Okay, for helium. So binding energy per nucleon is equal to delta MC squared, or EB is equal to delta M times 931.5 MEV over U. Okay, so we will use this equation since delta M here in unit U. So if your mass defect here in kg, then you can use this equation. Okay, so now let's proceed. EB is equal to delta M. We have calculated just now. It's equal to 8.285 exponent negative 3. Okay, and this is in U unit times 931.5 MEV over U. So we can cancel U and press your calculator. And finally, your binding energy is equal to 7.72 mega electron volt. Alright, so this is in unit electron volt. So if you want to change to joule, okay, so remember 1 electron volt is equal to berapa? 1 electron volt is equal to 1.6 exponent negative 19 joule. So you boleh tukar lah. Okay, buat 7.72 MeV. Kalau confuse darab ke bagi, buat darab silang. Okay, minus. So MeV ke atas. So now EV kat bawah, joule ke atas. So 1 EV, 1.6 exponent negative 19. So kalau awak tukarkan kepada joule, you dapatlah jawapan dalam unit joule. Try lah. Okay. So for this question, boleh guna in case delta M awak dalam kg sahaja. So if you use this equation, your answer would be in joule. Okay, tu beza di antara dua tu. Boleh? Okay, so proceed to question 10B, the last one. 10B. Okay, 10B. So NP element isotope with a half-life of 28 days decays into S element. So kita ada P with B decays to S, so kita ada energy. And given that the half-life is equal to 28 days. Okay. So determine the time required for 40% of the sample of P element isotope to become S nucleus. So let's say we have P element here. So initially, okay, the number of nuclei and not is 100%. Okay. So when 40% of the sample of P become S, so means that for the final one, okay, the number of nuclei for P will equal to 100 minus 40, dia akan tinggal 60%. Okay, so boleh kata kat sini, ini P initial, this is P final, the amount of P final, okay, 60% of its initial. Boleh dia tinggal 60% of its initial. Okay, so the final number of nuclei is 60% of its initial. So N should be equal to 0.6 N naught. Okay, N naught adalah N naught lah 100%. Kan? So sekarang kita nak kira apa? Okay, kita nak kira the time required for 40% of sample P tadi to become S nucleus. Okay, so we can use equation N. So since we know that the number of element P is equal to 0.6 N naught after P become S nucleus. Okay, so N equal to N naught E negative lambda T. So yang ni yang kita nak cari tu, T. Okay, so N is the number of nuclei for P. So 0.6 N naught, dia tinggal 60% daripada initial N naught tadi. N naught lah. Okay, initial, this is N naught is stand for the initial number, ataupun initial nuclei for P, and negative lambda T. So sekarang kita ada problem di mana we need to find first what is the decay constant, where lambda is equal to ln 2 over half-life. Okay, ln 2 over 28 days. So lambda is equal to 0.02476 per day. Okay, sebab dalam days kan tadi ni kita pakai. Kan? So yang kita boleh cancel, N naught boleh cancel. Alright. So 0.6 E negative. Okay, lambda is 0.02476 T. Okay, so boleh dah cari T. Okay, yang ni boleh guna calculator terus sebenarnya. You boleh dapat T. Ataupun you nak buat manual, boleh take ln for the both side. So E negative 0.02467 T. So this one can cancel. Okay, so ln 0.6 is equal to negative 0.5108 equal to negative 0.0. Ini boleh bawa ke depan kan? Matematik. 0.02476 T. Okay, so cancel T. Therefore, T is equal to 20.63 days. Okay, maknanya ianya mengambil masa 20.63 days for a P element to become S nucleus. Okay, so finish question number 10. Alright, so itu saja dari saya kali ini. Okay, insyaAllah jika kita berkesempatan, kita akan jumpa lagi dalam discussion untuk set yang ketiga. Okay, terima kasih dan jangan lupa share, like dan subscribe. Okay, jumpa lagi. Assalamualaikum dan selamat berusaha.